Welcome to lesson number 2. We're going to be looking at horizontal and vertical translations again. Now, we're going to be looking at a different notation, one that I used a little bit in the previous video. So we're looking at the replacement notation. So if I'm replacing y with y minus k, then we would use this, this mapping notation where all my y values get mapped to y minus k. Now this describes a vertical translation, so moving up or down. And similarly with my x values, I can replace those with x minus h. And so with my mapping notation, x would get mapped to x minus h, and that means my x values or my horizontal values are going to be changing either left or right. And depending on the value of those k or h values, your graph is going to move up if they're greater than 0, and they'll move down if they're less than 0. And if your h values are greater than 0, they'll move to the right. And if your h values are less than 0, they'll move to the left. So let's take a look at example number one, where we write the replacement for x and y, and we want to describe how the second function compares to the first function. So first of all, if I were to bring this 3 back over to this other side, this would be y mapped to y minus 3, right? Because if I bring this to the other side, it looks like this. Y minus 3 is equal to x to the power of 4. And this is going to be resulting, it's easier to see if we look at this function here, but this will result in a vertical translation 3 units up. If I look at this translation, my original function is y is equal to 6x minus 3, and I'm getting mapped to, or I'm changing my function to 6 times x minus 1 minus 3. And so now the only thing that's happening are my x values are being mapped to x minus 1. This is going to result in a horizontal translation, 1 unit right. This is an absolute value function which you can skip, but we can actually perform the replacements here. So first of all, my x values are getting mapped to x minus 6, and my y values will be getting mapped to y minus 2. Again, if I bring this positive 2 on the other side, that would be impacting my y values. So this would be a horizontal translation 6 units right, and a vertical translation 2 units up. And my last one, the only value that has been changed is is replacing my x. So x is replaced with x plus 1. So this results in a horizontal translation, 1 unit left. Now, if you look at example number 2, we want to write the replacements for x and y and the equation of the image of y equals x squared after horizontal translation of 3 units to the right. Well, 3 units to the right, x would be getting replaced with x minus 3. And so if we replace my x with x minus 3, this will result in x minus 3 squared. I replace my x value with x minus 3. We have y is equal to 10 to the power of x after a vertical translation of 2 units up. That means if it's going up, y is getting mapped to y minus 2. And if I replace y minus 2, or sorry, y with y minus 2, we could rearrange this to y is equal to 10 to the power of x minus 2. This last one, we have y is equal to square root of x after a horizontal translation of 4 units to the left and a vertical translation of 3 units down. So first of all, 4 units to the left would be a translation on my x value, and that would be getting mapped to x plus 4. And then if we move 3 units down, that's a translation on my y value, getting mapped to y plus 3. And so if I replace these x and y values, I would have y plus 3 is equal to square root of x plus 4. And again, we can rearrange this to y is equal to x plus 4 minus 3. In this next example, I'm looking at the graphs and trying to determine what the translations were on these graphs. And I'll just write, I have my, my transformation is the thick line, and my original function is the thin line. And so we'll see what happens when we go from here down to here. So even though it's an absolute value, we can still determine what happened to our function. So first of all, I went 2 units to the right, and so this means that my x values got mapped to x minus 2, and then I went down to 1, 2, 3, 4 units. So my y values then got mapped to y plus 4. If I think about what this equation would look like then, this would be y is equal to absolute value of x minus 2 minus 4. If I look at my next function, so if I'm starting at this one, I'll just start with this point, and then it moves up to this point here. Same with this one here, moves up to here. First of all, I move 1 unit to the right, and so if I'm moving 1 unit to the right, that means my x values are getting mapped to x minus 1, and I'm going 2 units up, and so my y values are getting mapped to y minus 2. And so if I insert these replacements into my equation, I'm going to be left with y is equal to 1 over x minus 1 plus 2. With this example, again, I only choose 1 point because it'll be the same thing happening on the other part of my function. So with this one, I'm moving 1, 2, 3, 4 units down. My original equation is just f of x. And so 4 units down, I would be mapping my y values to y plus 4. And then I could say y plus 4 is equal f of x, or y is equal to f of x minus 4. And I'll leave the last one for you, but just quickly here, 1, 2, 3 units to the right, and it looks like 4 units down. I'll let you get the equation. Last, we have y equals square root of x, and it's a radical function. So what vertical translation would be applied to y equals square root of x so that the translation image passes through 16 and 7? So what we want to do is we need to determine what this y replacement is going to be through y. So what vertical translation? So we're thinking about the replacement for our y value. And so we're going to use y minus k. And we're going to plug this into y minus k is equal to the square root of x, where y is equal to k is our radical function, and we're told that we're doing a vertical translation, and so we're going to solve for my k value. Now we're given 2 points here that we can substitute into our expression. So 7 minus k is equal to the square root of 16. 7 minus k is equal to 4, and if I switch my k and my 4 around, then I'm going to get 7 minus 4 is equal to k, or k is equal to 3. What this tells us then, if we were then to take this value of k and put it back into my value, so y is actually going to map to y minus 3, then this is going to result in a vertical translation 3 units up. And if we're looking for the horizontal translation, that would be applied so that the image passes through 17 and 8. We're actually going to take the exact same approach, and we're going to be mapping our x values to x minus h. And instead of replacing my k value, of course, we're replacing my x value. And this time, we're going to replace my x and y with 17 and 8, respectively. So 8 is equal to square root of 17 minus h. And if I take the square of both sides, so if I square both sides and get rid of this radical sign, and I'll have 64 is equal to 17 minus h. And again, if I switch around my h and my 7, I'm gonna have negative 64 plus 17, and h is equal to negative 47. Now, if I take this negative 47 and replace it back into my function, or into my replacement, then this is going to be a horizontal translation of 47 units left.